Welcome to our today's lesson, and in today's lesson we shall be looking at the halogens, or what is generally referred to as the group 7 elements. The objectives of the lesson is that by the end of today's lesson you should be able to mention the chemical properties of the halogens, the physical properties, as well as the uses of some of the halogens. As you can see on the board, we have elements that are referred to as halogens. They usually belong to group 7 of the periodic table. For the first 20 elements, we have fluorine followed by chlorine. The atomic number of fluorine is 9, while the atomic number of chlorine is 17. The other members that we have is number 1, bromine, which has an atomic number of 35, and iodine, which has an atomic number of 53, and then astatine, which has an atomic number of 85. For our lesson, we will focus on these first two members, as they are the ones that appear among the first 20 elements. So we look at the physical properties, and we begin with the electron configuration. So the electron configuration of fluorine, which has an atomic number of 9, is 2, 8, 2, is 7. If you want 2 and 7, you get 9, and that is the atomic number of fluorine. So if you were to write the atomic structure of fluorine, it would appear like this. So we have fluorine, and then we have the first energy level having 2 electrons, and then we have the second energy level having a total of 7 electrons. So you look at the second member, which is chlorine. Chlorine is atomic number 17, therefore its electron configuration is 2, 8, 7. Therefore, its atomic structure will look like this. We will have chlorine, and then we have the first energy level having a maximum of 2 electrons. Then we get to the second energy level with 8 electrons. So we have 1, 2, 3, 4, 5, 6, 7, 8 electrons. Then finally, we have the last, or the outermost energy level, containing a maximum of now 7 electrons. If you compare the two atoms, you note that for both of them, the outermost energy level has a maximum of 7 electrons. That's why the elements are said to be in group 7 of the periodic table. Comparing the atomic size, fluorine has a smaller size compared to chlorine. This is because chlorine has an additional 1 energy level, and that means that it has 3 energy levels, while fluorine has 2 energy levels. That is to mean, as we go down the group from fluorine, then we get to chlorine, the atomic size increases. The reason for that is because as you move down the group, there is an increase in the atomic size. That means bromine is the third largest of the members, followed by iodine and then astatine. The first member is fluorine, which is a gas, followed by chlorine, which is also a gas, and then we have bromine, which is a liquid, and then iodine and astatine are solids. Why do we have that thread? It's because all these members are molecular substances. And as you go down the group, there is increase in the molecular forces. Increase in size of the atom results to an increase in the molecular structure. As a result, down the group, the melting and the melting and boiling points are increasing. And that increase is what results to us having the first members as gases, then we have the third one as the liquid, and then the rest are solids. It is very important to note that all the members of the halogens are soluble in water. However, the solubility of halogens decrease down the group. That is to mean that fluorine is the most soluble, followed by chlorine, then we have bromine, iodine, and then astatine. So, on the appearance, fluorine is a pale yellow gas, while chlorine is a green yellow gas, bromine is a brown liquid, and iodine is a shiny dark solid. On the electrical conductivity, these elements are molecular substances, and therefore they do not contain electrons in the outermost energy level that are responsible for electrical conductivity. As a result, they are non-conductors of electricity. How can we explain this? For example, if we look at fluorine exists like this. We have fluorine, they are all diatomic molecules. And the fact that they are diatomic molecules is what results now to the molecular structure. They are molecular structures. So if you look at how they exist, you will know that we will have one fluorine atom having, if we use the last energy level, we have 7 electrons. All right? And then we have, if we were to have another fluorine atom like that with 7 electrons as well. So the last electron, the 7th electron, is usually shared among the 2 atoms. So we have this electron, that one electron from this fluorine here, and then we have this other electron coming from this fluorine. So for that case, you note that all the electrons have been used in forming the molecular substance. As a result, fluorine, chlorine, and other halogens do not conduct electric current. Reason, they are molecular substances, and molecular substances lack delocalized electrons or free electrons that are used for electrical conductivity. Next, we look at the rate of reaction. Down the group from fluorine to astatine, the rate of reaction decreases. That is to mean that fluorine is the most reactive, followed by chlorine, then you have bromine, and the process continues. Chlorine dissolves in water to form 2 compounds. we have chlorine, which is a gas, when reacted with water, liquid state, gives us two products. The first one is HCl, hydrochloric acid, plus chloric 1 acid. And all these are aqueous. They are all soluble. When you test the product of dissolving chlorine in water, the solution gives you, with a red litmus paper, it remains red. But then if you use a blue litmus paper to test the solution that is formed, you find that the blue litmus paper turns into red. And then after some time, it gets bleached. That is to mean that the color is removed. It is important to note that the bleaching effect of chlorine water, so chlorine water is the one that contains hydrochloric acid and chloric 1 acid. The bleaching effect of chlorine water, and I'm saying that this is what we call chlorine water, is as a result of chloric 1 acid. So in absence of chloric 1 acid, we don't have the bleaching effect of chlorine water. If you are to take or to leave this solution, which is called chlorine water, in presence of sunlight, you note that the oxygen atom here, the oxygen atoms that we have here, is usually lost to the atmosphere. And therefore, if you expose chlorine water for some time in the atmosphere, you find that it loses its bleaching effect. Why? Chlorine water will lose the oxygen atom, which is responsible for the bleaching effect. How does that happen? We have the chloric 1 acid exposed to the atmosphere. It gives us oxygen gas plus hydrochloric acid. And remember that hydrochloric acid itself has no bleaching effect. Class, note that this reaction only happens in presence of sunlight. In absence of sunlight, this reaction cannot take place. That is to mean that if you leave chlorine water in a dark room, this breakdown of chloric 1 acid to give us oxygen and hydrochloric acid does not happen. We look at electron affinity. So every time a chlorine atom loses an electron, or gains an electron, to form an ion, there is energy, there is an amount of energy that is released, not only for chlorine, for all the halogens. In this example, let us use chlorine. So if you have chlorine gas, and then it is as an atom, then it gains an electron to form a chlorine there is an amount of energy that is released in the process. This amount of energy that is released is called electron affinity. The electron affinity for chlorine, for example, is negative 349 kilojoules per mole. This one happens every time chlorine atom is forming an ion. An example is we have chlorine atom, which is chlorine having the first energy level with 2 electrons, and then we have the second energy level with 8 electrons, and then we have the last occupied energy level, which is that, of course, having 7 electrons. Every time now chlorine forms an ion, this ion is formed through loss of an electron, gaining of an electron. Why? The energy that is required to lose all the 7 electrons in the outermost energy level is very much high compared to the energy that is released in just gaining 1 electron. As a result, chlorine and any other nonmetal will form an ion by gaining an electron, just 1 electron. Every time that happens, it now becomes an ion with an extra 1 electron, and every time it has an extra 1 electron, the charge now becomes negative. Ideally, this is -1, but then 1 is very insignificant and we leave it as a negative. So every time this reaction takes place, every time this now takes place, there is an energy that is lost. That energy that is lost during this process now of the ion formation is what we call the electron affinity. The electron affinity for halogens usually decreases as the size of the atom increases. You got that? So the electron affinity, it will decrease as the size of the atom increases. That is to mean that the electron affinity of fluorine is the electron affinity of fluorine, therefore, is greater than the electron affinity of chlorine, and so is for bromine and the other atoms in group 7 of the periodic table. Electron affinity can simply be explained as the demand or the tendency of an atom to attract electrons to itself. So when we say that the affinity of fluorine is much higher, we simply mean that fluorine has a higher tendency to attract 1 electron towards its outermost energy level to form an ion than it would be for chlorine, for bromine, and the other halogens. As a result, the reactivity decreases down the group. As the affinity decreases down the group, so is the reactivity of the halogens. Next, we look at the chemical properties again. The reaction with metals, that is the reaction of the halogens with metals. We can use the example of chlorine in this case. Chlorine reacts with iron to form iron 3 chloride. How is that equation? We have chlorine, a gas, reacting with iron, it is a solid, to give us iron 3 chloride. In this case, it's a solid. Remember that iron is a transition element. Therefore, it has an oxidation. It can have an oxidation of 2 or an oxidation of 3. Let me write them better. An oxidation of 2 or an oxidation of 3. But due to the high affinity of the halogens, when chlorine is reacted with iron, it is able to get the maximum number of electrons that iron can give. As a result, the chloride of iron is never iron 2 chloride, but iron 3. Right? That is for chlorine. If we look at other examples, reaction of iodine in this case, we react now iron, which is a solid, reacted with iodine, which is a gas, which is, no, iodine is not in gaseous state, yes. It gives us iron 2 iodide. Why iron 2 iodide? And when we had chlorine, it was iron 3. It's because the electron affinity of iodine is much lower than that one of chlorine. With other metals like zinc, chlorine, we react with a metal like zinc, solid, reacted with now chlorine, which is a gas, gives us zinc chloride. Reacting it with bromine, zinc will react with bromine to give us the same product. We have, just need to change here and have bromine gas, and we have zinc 2 bromide. And that's all. That is the reaction now between metals and halogens. For iodine, it will be still the same. We have zinc plus iodine. We will form zinc iodide, which is not a gas. We need to correct here, class. It will be a solid. Yes, a solid. The reactivity of these elements, the group 7 elements, with metals is still the same as, okay, not the same, sorry, decreases down the group. That is to mean that reaction of fluorine with metals is, the rate is very high compared to the rate of, compared to that one of iodine with the same metal. We look at the reaction of the group 7 elements, which are in this case the halogens. And in this case, let's try to check now the product that will be formed if we react the same zinc with chlorine. So zinc, a solid, plus chlorine, which is a gas, gives us zinc 2 chloride, and the product is a solid. Class, if you look at that equation, it's already balanced. And so will be if we use other halogens. Because if elements are in the same group, then the number of electrons they gain or they lose is the same. So at that point, let's look at some of the uses of these elements. We begin with bromine. So small amounts of fluorines. Oh yes. I'm saying that small amounts of fluorines are used to prevent tooth decay, and they are used in the manufacture of toothpaste. Then we have fluorine. Is also used to produce the high temperature plastics, and also in its elemental form, fluorine is used in rocket fuel as an oxidizer, that is to raise the rate at which the fuel is burnt in those rockets. And then we have products containing bromine are used in agriculture and sanitization as fire retardants. Fire retardants means to reduce the rate at which such compounds burn. And then we have silver bromide is used with other compounds to manufacture light-sensitive photographic film, like the ones that are used in X-rays. Then for chlorine is used as a cleaning agent. Is actually ended in cleaning agents as a bleaching agent. Remember, when we speak about the cleaning action of chlorine, we say that when we are looking at the chemical properties, we say that if you take chlorine in aqueous state in water, it gives us chloric 1 acid. It gives us HOCl, that is chloric 1 acid, or hypochlorous acid, plus hydrochloric acid. The chloric 1 acid is the one that has the bleaching effect, and it bleaches through oxidation, through giving out this oxygen. So when this happens, the color is usually removed, and that is why when we dropped red litmus paper, in this case, in a beaker containing chlorine water, it gets bleached. And when we use blue litmus paper, it first turns red, indicating that the solution is acidic, and then immediately it gets bleached, meaning that it is removed color. So this property of chlorine water to remove color in substances makes it very useful in cleaning. And as a result, when we manufacture cleaning agents, when chlorine is added into it, it now gives the property of cleaning agents to remove the dirt in color. And that is why you have heard of something like we call it the jik. Jik is one of the products that contains chlorine, and jik, when added to clothes, it actually removes color. If you take a white cloth that has a stain, a black stain, and then you soak it in jik, the stain can no longer be seen because that color has been removed from it. And then again, chlorine is also added in small amount to treat water by killing the microorganisms. And then finally, chlorine is used in the manufacture of plastics. This is just a few of the uses of the not alkaline earth metals, These are the uses of halogens. Yes. So thank you for watching this lesson. You share with your friends so that together we build a world of chemistry, or an ocean of chemistry. Thank you.